Hello, my name's Keegan Neve. Welcome to Neve Engineering. Today we'll be talking about PiWars 2021, these two robots here, and kind of what went wrong. So yeah, stay tuned. Right, so those who've been following, I entered PiWars 2021, which was an at-home competition this time around, rather than in person because the world's still on fire. And it was a fantastic competition. The challenges were very challenging. Go and watch the live stream and go through the videos that the other competitors put up, because some of the solutions are just superb to some of the challenges. And yeah, great day was had by all. And unfortunately, I didn't quite make it. So as you can see, I've got two robots here. McFeagle Prime, the original robot from last year, and NE5, which is the one I've been talking about for a while, which is the brand new design that I entered into PiWars 2021. Now, there's an awful lot of improvements between these, which I'll go through in a minute. But yeah, basically I got to the point where I was able to submit an artistic and technical merit video, which I still did quite well with. So I think I came 6th or 7th for artistic and technical merit, because they were judged separately. So very happy with that, to be honest, considering I didn't actually manage any of the challenges. It was, and the rest of the competitors, the quality there, I was happy with that. So what went wrong? So as you can see, the robot is very similar to the last one, but completely redesigned, and everything is completely different and designed again from scratch, apart from I reused the drive wheels and this link here, which you might just about be able to see. This square looking thing holds two servos, and his left wrist's a bit worse for wear. I had to steal some servos to get NE5 working. Those are literally the only two parts I reused. Everything else was designed again from scratch, because frankly, got me started and inspired an awful lot of work on my part. But yeah, I've learned a lot since then about CAD. So functionally, I'll share some videos. This robot would have been able to do the challenges had I not cocked up. It was one little thing which is incredibly frustrating, but you live and learn. So all of the testing I did was on Wi-Fi here in the living room, and when I actually came to do the challenges, because I don't have room here, I built a little arena up in the workshop, which is definitely a work in progress, that doesn't have Wi-Fi. So I was just able to connect to the house Wi-Fi, because NE5 has a natty external aerial, but the lag was too bad. So anytime I was trying to drive it around using the controller, same as last time, basically it'd lose. The latency was bad enough, it would drive into the sides, the arms would start moving, and because it didn't receive the stop signal, it kind of carried on going until things fell off and snapped and all the rest of it. So I switched to using the Wi-Fi hotspot on my phone. I've done that a few times with McFeagle Prime, seemed to work a treat. This time around, for reasons unknown, I needed to add one environmental variable, which is frustrating as all hell. It was literally just one environmental variable. When all of the various components of ROS, the robot operating system, talk to each other, they connect to what is still referred to as the master node. Nomenclature aside, they say, right, I'm here. So when you connect a subscriber or a publisher from a different machine, counting each of these as a machine, and this, it says, here I am, this is me. Now, what I also had to do this time around was on the controller, I needed to specify the host name of this controller. So I had to say ROS_hostname equals controller. That was it. That was all that needed to happen, because basically this was able to send messages to the ROS master node in the head of the robot, but it wasn't able to send anything back, so it didn't authenticate or something along those lines. So basically the ROS core master node, the ROS master, ignored them all. So none of the control messages were getting through. It could see, the controller could still see all the topics, so it could receive things, but for whatever reason, it wouldn't accept control signals until I set that, which is something I figured out a few days after the competition deadline. So that was frustrating, but again, had I started a month earlier, because I was working a month solidly on this, which I thought would have been enough time, I'd have probably caught this sooner, or had the Wi-Fi working in the garage. But anyway, so that's what went wrong. What went right? So, pretty much everything else, other than almost burning myself out. Again, like I say, should have started a long time beforehand. I thought with all of the background work I'd been doing on McFeegle Prime, it had put me in good stead to just kind of, in a couple of weeks, throw the new robot together, because it is essentially the same design, just done from scratch, and more components in Fusion and all the rest of it. So it was what took me a good couple of months, close to 3 or 4 months to get this working. Took essentially a couple of weeks to get the basics done on this. And the arms, again, designed again from scratch, but they didn't take long, because I was basically reproducing the design from McFeegle Prime over here, and yeah, it just didn't take long in general. So all of the mechanics work a treat. I've even managed to get a few aesthetic tweaks done, so you can see I've got the, I can't remember what they call it, gurneys? Nurnies, I think they call them in the Johnny 5 community. So these are what I'd call greeblies, taken from the head of Johnny 5. There was a movie in that somewhere, but these are actually 3D printed, just a little aesthetic tweak. And also you can see the vents on this side. These are functional. So they're not just done for the look of it, though they do look cool. They are air vents, and they actually are exhausts from the fan in the back. And this time around, I actually did a fan grill from the start. So that was a nice and easy little thing. You can see the size difference between the two of them. So if you put them side by side, they can stand up to the same sort of height. I think this one might, yeah, they can stand up to the same sort of height, but overall, NE5 is just that bit smaller, a bit more compact, and considerably lighter. So I just weighed these, and McFeegle Prime comes in at 4.96 kilograms, and NE5 comes in at 3.5. So that's 1.5 kilograms savings, and that's all in the batteries. So the old MFP McFeegle Prime had a ridiculously large battery, which I will admit now, it was something like 3S6P, so it had like 18, I'm not very good at maths, 18 or so cells. And you can see a lot of the torso is just incredibly chunky, over-engineered to say the least. So all of the walls and everything on the new robot are that bit thinner, considerably quicker to print as a result. And it's a lot more modular. So overall, there's just lots of little weight savings here and there. The biggest difference between the two is probably the fact it now has 2 Raspberry Pis. So as you can see, it currently has a caboose, which is held on with a strap at the minute because I slightly messed up with the length of the cover, so it doesn't quite fit on to be screwed in place, which is annoying, but c'est la vie. This contains the Redboard Plus by Neil Lambeth's Red Robotics. This is a motor controller and servo controller hat for the Raspberry Pi. Absolutely brilliant bit of kit. The same one that McFeegle Prime is using in his head. So you can just see it there. And yeah, brilliant bit of kit. But with McFeegle Prime, we have this mess of cables. So all of the power from the battery goes up to the head, through the hat on top of the stereo Pi board, and then you've got a bunch of servos going back out to, I think, the head, the neck, and it was supposed to be the torso control. You've also got the power going back down, the control leads going back down for the 4 motors. You've got all sorts of stuff, and basically this chunk of cables was stiff enough, because of the sheer number of them, that in an early iteration for this, if you moved his head back, it would pop off. Not ideal. It also meant I had to have these chunkier servos, the MG996Rs, which are big, and again, they just take up a lot of room. So in this new version, I split it in two. So you've got a Raspberry Pi Zero in his caboose, and up top in his head with another magnetic fitting head, we have a Stereo Pi version 2. So the folks at Stereo Pi were good enough to send me a version 2 board to test with, and you can probably just about see it under there. Probably much easier if I turn to the side. But yeah, it's up there, and all that is up there is a Raspberry Pi and an Arduino for reasons I'll get to in a second. Now, the Raspberry Pi, the Stereo Pi is running a Compute Module 4. This is the version with 4 gig of RAM and the onboard Wi-Fi, hence the little aerial, because it's got an external connector, and frankly, it looks cool. It is literally the brains of the operation. It runs ROS Core. It is going to be doing all of the stereo calculations and all the rest of it. It is still going to be doing the lion's share of the work. But where on the older robots we have that massive bundle, we literally have these 3 cables, and that's it. So all of these replaced with these, and this is a power. This is just power in. There's a little 5-volt voltage regulator in the head or is in his bottom. I can't quite remember where it is, but there's 5 volts going up to the Stereo Pi V2, and there is a USB cable coming out. Now, the bit messy under here because it just is, but the Pi Zero is actually in what is called Gadget Mode. So if you're not aware, with the Pi Zero, you can put it into a mode such that when you plug it into a power, where you'd normally power it with a USB cable, you can plug that into a computer and it will register as a device of some kind that you can specify. In this case, I've set it up as an Ethernet gadget. What that means is when you plug this into a computer, it presents itself as a network interface. So a USB network card, essentially. That cable is then plugged into the Stereo Pi as a guest device of the Stereo Pi. And the Stereo Pi can then talk to the Pi Zero down here over the USB network connection. So it's really simple to get these talking to each other, and it works an absolute treat. I'm really happy with it. Where before for testing I was using it's this Pi Zero W, just in case I want to get direct access to it. With them both on the Wi-Fi, I was getting somewhere in the region of 5 milliseconds latency between the two, which wasn't too bad. But when I put it on the USB Ethernet, it dropped to 0.5 milliseconds consistently. It was the ping was, well, for my purposes, non-existent. So incredibly happy with that. Again, definitely sticking to this formula. It works an absolute treat. So what's next? And one thing I will show quickly, that as well as the aesthetic tweaks from the 3D printed parts. Come on, you little bugger. There we go. Some of these new servos are quite stiff, so it's difficult to shift them around a bit. But one of the wonderful aesthetics I was determined to add was the lights around his eyes. So these are 12 LED NeoPixel clones, essentially. They're the Cool Components ones. I just use Cool Components. They're nice and cheap, and they deliver them next day. They work a treat. Used them on all sorts of projects. And yeah, so these are fully controllable. I'm going to be able to turn them red when he gets angry and all the rest of it. So that's what the Arduino is currently doing. It's powering the LED lights. The LEDs. The other thing the Arduino will be doing is controlling the eyebrows. So I put a ridiculous amount of effort into having these so they could be actuated. And not currently fitted. I have a pair of a mount top and bottom for these. I think they're called nano servos. They're like 1.6 grams compared to the 9 grams that these larger ones are on his wrist. These will be able to make it so the eyebrows open and close. I can't do the tilting yet. I'm determined to at some point, but frankly, I've got bigger fish to fry. And the other big thing with this is that I have been putting a renewed concerted effort into learning the robot operating system. So I've been going through more of the courses on the Robot Ignite Academy, not sponsored, they're just really good at teaching you how to use ROS. And I've learned how to generate URDF, Universal Robot Definition files for a robot. Currently going through and learning ROS control, which lets you control actuators. And also the next course I think is kinematics of robot arms. So that'll be nice and that'll be handy. So yeah, I'm carrying on with that in anger, as it were, and I'll be releasing videos showing progress as I go with those. I'll also link, well, I'll put a link to it in the description, but there's the artistic merit video I put together, which shows the robot playing lacrosse because things weren't difficult enough. This was my solution for the Feed the Fish challenge. It's a tiny little lacrosse stick kind of thing. You can just see a pair of rails in there. Basically, you put a Nerf rival ball in there. The robot was able to go through a set of motions to fling it, and really annoyingly, I got really good range and really good accuracy with this. I managed to get 15 in a row. So I would have had quite good scores for that one had I actually been able to do the challenge. Still, there's next time, and I'm still going to go through and do the challenges just as a matter of pride more than anything. So I'm still going to get this done. So stay tuned for those. And yeah, thanks for the continued support of my patrons. I'll put a thing across here, which is probably going to be on the other side of the screen. But yeah, if you're able to support me on there, that would be brilliant. If not, if you can subscribe and share these videos, that helps a massive amount. It really does. And yeah, other than that, stay tuned for the next video, and bye for now.